CISOs always say, we want to be that business enabler.
Yes,
this is the opportunity.
This is a business enablement. This is what you do.
This is the opportunity.
This is what you do. This is how you reinvent security.
How I saw it transform these consortia, they started with sharing small spreadsheets. And now all of a sudden they energized this whole community. Yeah. And now the community is working on data, but they're also offline coming together for maybe hunting.
Solving the actual problem.
For solving the problem. So it's also a motivator.
Welcome to Reinvent Security, the podcast where we look at ways to reinvent information security together with industry leaders. My name is Jeroen Prinse. I'm a freelance Chief Information Security Officer, public speaker, trainer and coach, and co-host of this podcast. I have nearly 2 decades of experience in the field of information security, and I'm here today with my friend and co-founder of this podcast, Irfaan Santoe.
I am Irfaan Santoe, a security executive, last chapter leader, book author, and public speaker on information security. And I'm extremely passionate about solving the information security problem.
So today, the topic of our podcast will be something that is called multi-party computation. And it's a way, I think, that we can collaborate with others and derive value from shared data without exposing it to the myriad of risks that comes with it. So today we are unraveling some of the complexities of multi-party computation, a revolutionary approach that's transforming the landscape of information security, in my opinion. Because in an era where we face the challenge of securely analyzing and sharing sensitive information has never been more critical to organizations. And data breaches are not just a common threat, I think, but they are definitely a common headline. So multi-party computation can offer a promising solution to enable us to analyze collectively data for insights without ever revealing the actual data itself. And today on the podcast, we have somebody who is extremely knowledgeable about the subject. So let's dive deep together with Toon Segers and answer questions like, how can MPC not just enhance our collaborative efforts across organizations, but do so while upholding paramount principles like confidentiality. So stay tuned as we explore the groundbreaking technology with Toon Segers, co-founder at Roseman Labs and PhD candidate in mathematics and cryptography at Eindhoven University of Technology. And previously, Toon was a partner in the cybersecurity practice of Deloitte. Welcome, Toon.
Thank you very much. It's a real pleasure to be here.
Good to have you here, man. Could you please introduce yourself in your own words and tell us about the work that you are doing in the field of MPC?
Yes. Yeah, I'm a co-founder of Roseman Labs. So a company that offers MPC as a platform for organizations that like to collaborate on sensitive data. Mm-hmm. As you said, I'm a PhD candidate in Eindhoven on the topic of multi-party computation. So in sort of the few spare hours, I try to do some research on the topic as well. I have a mathematics background. And my key role in Roseman Labs is Head of Customer Success, which is a fancy title for saying I support our customers in getting their stuff done. Yeah. And I really enjoy doing that.
Cool. Yeah, so a PhD in MPC, so that, or at least in cryptography and specifically in multi-party computation. So that means that you know a lot about the subject, I assume. You created a company that creates a service around the technology multi-party computation, right?
That's correct. Yeah.
So we always ask our guests, how are you contributing to reinventing security? And maybe more specifically with the use of MPC. Could you share some light on that?
Yeah, I would love to. So maybe one step back, multi-party computation is a technique to run analyses on data while the data remains encrypted. Mm-hmm. So that's of course a bit of a paradigm switch.
Yes, I can imagine that for the listeners that is like new to them.
It is, and sometimes also when I explain it to people, so you run the analysis and the data remains encrypted, they ask, but then you decrypt the data in memory at some point and then you encrypt it again. And then I say, no, it stays encrypted from the moment you enter the data into the platform until you expose the result of the analysis. Everything remains encrypted. And I think that's indeed a feature and a paradigm shift. But what it allows you to do is to share more sensitive data that you would love to combine and collaborate on with partners. and you can run collaborative analysis on each other's data, and that's pretty powerful.
Yeah.
And to your question, where was it used or where is it used? Our first customer was the National Cybersecurity Center.
Yeah.
And it is the foundation for their platform called SecureNet. And SecureNet is a public-private partnership collaboration platform to get more data from partners in the field, security companies or vital organizations that were sometimes hesitant to share this sensitive cyber threat intel that could be very valuable for National Cybersecurity Center.
Yes.
So, for example, when the war in Ukraine started, we saw we were afraid more cyber threats would happen. And we could survey the field, the partners of NCEC, saying, do you see more attacks? Do you see more risk? And these questions could be submitted by the partners of NCEC, and they could see the aggregates, but not the individual responses, because that was the encrypted data that went in. Nobody got exposed. Everybody stayed their data stayed confidential, but NCEC could make statistics that could give them a view of the threat landscape.
Yeah.
And that's, I think, sort of a good example of how it all started in the Netherlands.
Yeah.
Wow.
Cool.
Wow. I think the applications of this sort of technology is immense, right? It's not only within cybersecurity. Just think of other platforms. I know, have been working for a bank. They also had a challenge. Okay, how do I share transactional data with each other as banks to basically combat your customer sort of challenges?
Indeed.
I think the application is used just not only information security, Toon. So can you just speak a little bit towards what sort of other problem statements you can solve very specifically from the industry on this one?
Absolutely, yeah. So in our journey and in my role, we have now supported 15 consortia, and it varies from it started with National Cybersecurity Center, so we're very proud of that. But the last one that we onboarded was Amphia Hospital in Breda.
Okay.
And many people in healthcare know that we have a healthcare infarct. There's too much. The costs are rising, and there are too little healthcare professionals that can do the work, and because of the aging population and other factors, and particularly this aging population, we need to streamline how we give care to elderly people in regions that see aging a lot. So in Zeeland or in Breda is also there's an aging population there. Yeah. Particularly. And so the elderly care organizations and Amphia, they need to collaborate on their, let's call it supply chain or their care chain. You get admitted to the hospital, then you get released from the hospital, you go to maybe home care or revalidation. But these paths, these care paths, sometimes get stuck. People are sitting on the wrong bed for too long, and that's a big cost burden. But it's a supply chain, and you could run analyses over your supply chain if you could combine the data from these organizations into one data analysis platform. So that's the last case we onboarded, is they want to streamline their supply chain by combining all the data from their partners. And it ranges from cybersecurity collaboration to healthcare collaboration or banking, as you said.
Yeah. Amazing.
Yeah.
Amazing.
Yeah. So just to summarize, right, Toon? So to explain multi-party computation in like layman's terms, it's, I think, a solution where you can collaborate with others, maybe even competitors or peers within your industry, to work together on data, to do analysis on data without ever decrypting it.
Yep.
And I think the additional security benefit is also that you are storing it at multi-parties, right? Because it's multi-party computation.
Yeah.
So that would mean that you would store it at least over 3 different partners. So as a attacker, you need to hack 3 different companies to be able to access all data, and then you still need to decrypt it, right? So it's also a way of more securely storing your data. More securely storing your data. Yeah.
Your previous guest, Rob van der Veer from Software Improvement Group, they did a security audit on our technology, sort of at the code level, so code review. And their statement was, and there are different techniques of there are different flavors of multi-party computation. There's also MPC that you can run with 2 parties, and MPC that you can run with 1,000 parties. And we have the flavor where you need to compromise 2 data centers out of 3 to break the security. And that's exactly how they stated it in their report. It's this can withstand a compromise of an entire data center, and still it can recover from that attack. And that's a pretty, it's a security benefit, I would say.
Yeah,
for sure.
To me, I always found that mind-boggling, right? That you have a function, that you call on the data, and that you process it unencrypted, or at least that you process it without it ever being unencrypted. So how does multi-party computation allow multiple parties to compute a function together without revealing, for example, the inputs or the question that they are
asking? How does it work?
How does it work?
Yes. What's going on?
What's going on? What kind of voodoo magic is this?
So you need a little bit of a degree in mathematics to go down into the details. And what was really interesting when Software Improvement Group did the audit, they also in their team or in their extended network, they found 2 cryptographers that were sort of well versed into sort of cryptography, and I think that was quite unique of that assessment. But also, we could level with these people. I think how it works. Maybe the simplest example is if you have 2 numbers, and you want to add them together, but you don't want to see it. For example, in an election.
Yeah,
we're voting. And you have a vote, and you have a vote, a 0 or a 1, a yes or a no. And how do you do that? And I think the simplest way of looking at it is if you create 2 random numbers and your vote is a 1, Irfaan. And maybe say the random number is 15 and minus 14. Individually, they are perfectly random, but if you add them together, you're back to your 1.
Yeah.
And now Jeroen does the same. So his is a no vote. And he draws a random number, minus 99, and plus 99 is the other random number. Of course, they're correlated, but if you see them individually, they're perfectly random. So, interesting side note, if a quantum attacker finds your 99, it's perfectly useless information. We call that in cryptography, we call it information theoretic. There's no trapdoor in that piece of information. There's no weakness there. It's just a 99 that's perfectly random. But if you have both numbers, then the security is over. So, but the funny thing is, so now we need 2 computers, and you send your random numbers to computer 1 and 2, distributed, and you do the same. Now these two computers, they only see their random halves.
Yes,
we call those secret shares. And if you add them up, you still have a random number. So I'm one of the computers doing the tallying of this voting, and if I add up my random numbers that I have received, it's still random. And the other computer does the same. But if we now add them together, we get the output of the election. And that's sort of a way of thinking of it. It's a bit of a simplified example because you want to do multiplication and you want to do comparison and all the way you build your computation graphs to do neural nets and AI on encrypted data. But you start with the small building blocks like these.
So if I summarize that correctly, it's basically every node, every computer that is involved with multi-party computation does its own calculation. And when you combine the results of that calculation, you will get the answer that you were looking for.
Exactly. Yeah.
Okay, cool. So you already shared some of compelling real-world scenarios where we could use MPC, right? So we talked about SecureNet of the Dutch National Cybersecurity Center as one example. How did some of the real-world scenarios that you've seen solve specific problems that, for example, security officers were facing in their day-to-day job that, for example, traditional encryption like IAS 256 or other privacy-enhancing technologies like pseudonymization or anonymization technology couldn't?
How is this better?
That is
what makes this better.
Why?
So if you look at if you take the GDPR, for example, and it has sort of these principles of what is privacy, and it is, you have to minimize the data that you share, data minimization. You want to bound it to a purpose. It needs to be purpose bound. You cannot just do whatever you like with the data if you get it from patients, for example. Control. You want the data owners to have control, and all these sort of sometimes a bit abstract notions of privacy. You can solve those, or you can solve a lot with these techniques. And so how we do that in our way is, you're not sharing. The old way of sharing data is emailing spreadsheets around. And that's, for example, and it's not completely.
So you're competing against Excel. That's what we are saying.
And we would love to outcompete them. No, indeed, and it is well known. That's like you have this master data database, and then there's in a well-meaning organization, all of a sudden 2 years later, there's 20 copies of that database. That's not data minimization. So what you do in our situation is you encrypt it first, you share it in the platform, and if you're done, you can wipe the platform and you've done your collaboration. You don't need to, that spreadsheet does not need to be at your neighbor anymore. So that's purpose binding is another interesting fact, because we have these multiple servers that need to agree that they perform a computation. We let them check signatures on the computation. So a computation needs to be agreed by several approvers. And the servers that perform the computation, they check if all the approvers have approved. So that's sort of a consensus mechanism. And the funny thing with that is that you cannot run computations on that data without approvals. So there's your purpose binding. So you can even have, like, say you're working on the grid and you want to, one of our customers,
like the electric grid,
grid, and you want to detect where it's a very acute problem at the moment that the low voltage grid is congested. Ideally, you'd use smart metering data for that. So you would want to unlock the smart meter data, so to know in which cables are the most congestion issues when electric cars are being charged and so on.
So between 4 and 7.
Between 4 and 7, and then the solar panels, and then the heat pumps, and everything goes on the same time. But you want
electric cooking, lights.
So you need behavioral data, and the smart meter has that behavioral data, but you cannot use it at the granular level because it's very sensitive. But if you can, you're only interested in the aggregates of an area or a cable. Now, so you can approve on only those analyses that produce aggregates on cables. And now you don't know anymore that your cooker went off, but it is of the whole, cable street. So I think that's purpose binding.
As an organization, you have the control over what kind of querying or what kind of analysis you can do over the data, right? So it's like an authorized question that you can ask to the data.
Indeed, and in that governance or that signing function, you can even put a consumer organization and give them a digital signature option. So,
cool. So like a third party that actually protects the analysis that you can do on the data that you gathered.
Indeed, sort of represents the values of one of the stakeholders in the whole collaboration.
Nice.
So it's in that sense, I think it is. You alluded to the security benefits of you need to compromise more than normal. And there's privacy benefits, and that's why. There's also legal experts that say, you can do more in this model because you're working privacy by design. Now we can access the smart meter data, but we need all these safeguards in place, and we still need to inform the households that we're doing this, and they can opt out. But all of a sudden we can use this data, and that's, I think, pretty powerful because we're respecting their privacy.
You said data minimization and purpose bounding. Are there any other principles in privacy that you see with multi-party computation?
You have this notion of technical and organizational safeguards in the GDPR, and that's what we just talked about, right? The technical safeguards is the data center compromise or protection of it, and the organizational safeguards is this whole governance. That's by you bake the governance into the product.
Into the product itself. Maybe a question for me and also for our listeners, Jeroen, because I think you have, of course, a little bit deeper understanding as you guys are working together as well at the NCSC. But for the audience, is the problem, the business IT problem that we're trying to solve using MPC, is that already being solved by traditional security metrics or security controls with a compromise? Is that already happened? Like with a compromise, I mean, a compromise on privacy, a compromise on confidentiality, that other parties also have access to the data. Like, I'm trying to understand, is this solving a problem that we were not able to solve in the past without compromises? That's what I'm trying to understand.
I think let me try to give a first answer. And then I think why we focused a lot on the healthcare sector is because they were already very experienced with collaborating in multi-center studies. But the old way is you have to pseudonymize the data, to Jeroen's point. So the old way of doing it was you send your data to a trusted third party. They do the pseudonymization step, you receive your data set back, and then you can submit it to your multi-center study. But in my opinion, it is to a degree not not so privacy centric, because we all know that from a pseudonymized data set, you can still infer a lot of information. So now that spreadsheet gets still sent around.
Yeah.
And I think we can do stuff or today you can do stuff already, but it is clunky. In many cases, it's not privacy centric, and you need to make this round trip to the.
So there's more risk to the data as well, in terms of supply chain attacks, right? Because if one organization is compromised, probably because the data is going to multiple organizations,
Exactly.
and you're still able to extract some information from the data. It is not without losing the advantage on security. You're still losing some advantage of the security in the traditional way of things.
Yeah, indeed.
Okay.
Yeah. And I think you're dependent on this trusted party that sort of does the pseudonymization step, and you always have to sort of send it. You have to evaluate whether you find it pseudonymized enough. Send it back. The privacy officer reviews it again. Maybe this column needs to be removed. You want to do this you want to collaborate without sort of having to check in with another party. You want to do it by yourself and be in control.
What are some of the most significant technical challenges that you see when companies are implementing multi-party computation, maybe especially in complex environments? But
you can imagine that. I think the main technical challenge is the network. So if you punch holes through the enterprise network to go set up a connection with the other enterprise partner, you go to 3-4 firewall layers, and load balancers, and those kind of things.
Tell us about it.
Tell us about it.
Your audience and you know. So I think, and we need these nodes, these compute nodes. They communicate during the computation. So the benefit of splitting it up over multiple computers is that you have higher performance than with traditional means of computing on encrypted data. So you could say there's two flavors. The fully homomorphic encryption flavor. You don't need these multiple computers. You can run your encrypted computation on one node, but it's not scalable or not fast. The benefit of having it split across 3 computers is that you work with different mathematics that are more favorable to scaling. But there, the downside is the communication over the network, and so these stable network connections and these firewall and these routes is the headache that you need to overcome. So once you have set up nice pipes between these 3 computers, and what we are seeing is that a lot of our customers, I think over half now, are willing to procure it SaaS. So then we become a trusted party. We have 3 admin teams that run 3 nodes in 3 different clouds on European soil, but we can control the networking. Yep. So there's an admin team that makes sure that this this server is maintained and they are resourced. The trusted channel or the secure channels are set up, so that you need to trust us that we do the setup properly. But then it runs again with the same principles as if you're distributing over different entities. And I think we're now experimenting more with offering this SaaS option as almost as a default feature, because you still have a lot of the benefits, but you do need to trust us that we do the segregation of duties internally properly. But it takes away a lot of the headaches for customers, because then it's plug and play.
Yeah, because they would go through the same process to any sort of interfacing that's being done. So they would ask the same question to anyone, but now they're asking only to you guys. So you can set it up properly and then ensure, it's more efficient.
The only thing then the customers need is the client. So it's a web client or a Python client, and then the whole server infrastructure is just managed for them. And I think it's a real headache, the connections. And this SaaS model is, I think, one of the solutions that we found for it.
Yeah, I think also like the computational overhead, right? So MPC is like you have to have some computing power to do so. And I think that when you split it up over multiple nodes, then it will become more easy to compute it, because the calculations are just smaller, I think.
No, I can. It is different mathematical foundation that makes it faster. But indeed, it's not that the more nodes you spin up, the faster your computation goes. No. It's but in our model, it scales over cores, over CPU cores. So if you give the machines more cores, you can speed up. I think, but we always say what it can do and what it cannot do. MPC in our product, it's very good in joining data, in running regression analysis. But like these large, enormous neural nets that are now hip, we're not in the big data game. I think we stop at 100 million records. If you have a table with 100 million records and you want to do another join with another big table, that's sort of at pushing the boundary.
Yeah.
And then our compute nodes are typically like 8 cores, 32 gig of RAM.
That's
And if you have
manageable.
it's manageable. It's commodity hardware.
Yeah.
And if you need a really large workload, we spin up temporarily like a big machine and spin it down again. So that's that's also the benefit of SaaS, that the resourcing can be a bit more customized towards the type of analysis you want to run. We can temporarily just put bigger nodes on the job.
Yeah, would that also like be your recommendation then when a company wants to work with multi-party computation for either solving a business problem or solving a security problem, to either procure a service like SaaS MPC just as a service, or spin it up in the cloud because of the scalability there? And
I would say so. I think it's we're learning that you still have a lot of benefits and not a hassle. And there's always customers that want to hold on to their own nodes.
In general, we're seeing the IT landscape more for SaaSing. We see that happening anyhow, right? So there are true benefits to going through a SaaS solution in general. It's not only specific, I would say, to what you're offering.
So are there any like new vulnerabilities that multi-party computation would introduce into a landscape? Whether you're going for SaaS, I can imagine that SaaS will not introduce that many new vulnerabilities, but if you run it yourself.
Yeah, I think so. It is. You can do a denial of service if you knock over one node. So that's, for example, something you need to be mindful of. I think if you are running a critical process that is, every hour is running for a bank, a large amount of volume, and your primary processes are dependent on this, you need to think about, okay, these nodes should not be knocked down, or it should be redundant. If one is knocked down, you can spin up the second. So I think that's an important new dimension to and I think it's cryptography. It's built by cryptographers, and you should assure that it's built by cryptographers. I think that's so you want to understand sort of there's a whole cryptographic chain from approving an analysis to validating it on the server, and then and there's keys involved, and there's so it's always good to do an audit or rely on an audit that has been performed, or a pen test. So it's a complex system. I think we're offering it in a way that's pretty user friendly, but you want to understand, as a CISO, you want to understand the technology. You don't need to understand the mathematics, but you want to understand, okay, where are the secret keys? What are the secrets in this system? And where are the weak spots, and are they controlled? And we provide these reports, like transparent reports about how was the code reviewed and so on. And I think that's an important thing to take into consideration.
Yeah, it also contributes to trust, right? So when you either buy a product, or if you, want to do multi-party computation yourself, which I wouldn't recommend for like the majority of companies, since it requires a significant amount of development, but also like...
It's a food gun.
Yeah, like
then
MPC,
you're rolling your
right?
own crypto.
Just like the first rule of crypto is never do your own crypto, right? I can imagine that it also says something about the trust that you have in a system, or in a product that you're buying, or in an implementation that you're doing, right? So
I think if you and you guys probably know this much better than I, but if you are implementing a cryptography product, you want it to be implemented by people who understand that kind of stuff. So there are great open source frameworks out there. One that's by the Eindhoven University of Technology, and our scientific advisor, Berit Schoenmakers, is called MPyC. It's very simple to kick off, but to make a production grade setting, then I would say it's you need cryptographic expertise to set it up.
Do that, which is already a scarce resource in any sort of CISO department.
Yeah, so Toon, looking ahead, how do you see multi-party computation evolving over the, let's say, upcoming 5 years? Are there like any specific emerging trends or technologies that you think could significantly enhance its capabilities, or the application of MPC itself?
I think there's the engineering side, and there's the scientific side to this sort of pushing the boundary of. We're very proud. We were the first, as far as we know, that implemented the regex function in MPC. So you get a string, and you want to see if there's like a certain character pattern in that string. And one of our scientists, he found out that it's a finite state automata, and you can implement that finite state automata in MPC. So this goes beyond my sort of technical knowledge, and it worked. I think if you wanted to run it on 1 million rows, 1 million strings, you needed to run it for a day or something like that. So if it's not a critical job, on a, I'm guessing 8 or 16 core machine. Not the commodity hardware still. So a day. Okay, that's nice, but that's a big workload. And then we found out that there's a lot of comparisons in this in this computational circuit, and some of those comparisons you could amortize. You could not postpone and then do just one very efficient step. And that was that's a theoretical breakthrough. So there's you have the implementation, and then there's in our model, the costs of doing certain computations are different. So you're playing with these parameters. And Mylov, in this case, he saw a way to do it much smarter, and it became 50 times smarter or 50 times faster. So that's, I think, and these you'll see that it's now a very active computing on encrypted data is a very active academic field at the moment. And so you see these tricks being found and leading to speed up. So I believe there's still a lot of academic gains. Yeah. And then there's the engineering side, and that's I think how we started. So Nick, our CTO, he started with the idea, if he sees the Moore's law is tapering out, but we're compensating with cores. Putting just more cores on the problem.
Yeah.
And so he built our engine from the ground up, but natively to scale over cores and CPU cores, not GPU cores. And now we went through this Intel program. It's called Intel Liftoff, and they said, you want to play with our latest how the data center will look in 3 years or 5 years from now is this machine. I don't know the name of it, but it has 192 CPUs. I don't know how many cores, and 1 terabyte of RAM. So wow. That's sort of the future of the data center. And by luck, but by engineering, that's exactly the kind
way
of platform.
you scaled it. You scaled the platform as well. Yeah.
We've never looked at GPUs, and our CTO was saying that because the memory bus from to the GPU cores is slow, that was not so interesting for us at the moment. But it could very well improve and then become interesting. So on the engineering side, I think one of the things we are excited about is to make it very scalable over cores, because there's a lot of network communication during a computation. But funnily enough, in many of the use cases, it's CPU bound. So still the CPU is the bottleneck. Because we have big pipes between the compute nodes, and we don't need a lot of pipes.
And do you really see, Toon, that's the question over here as well, is do you see that business case growing that you need faster computations? I mean, it's a nice engineering problem to solve. You've solved it. But how applicable is that to the business as well? Because is this data they would like to compute, to analyze real time? Or is it a monthly basis or a yearly basis? I'm trying to understand the business problem we're trying to solve for this as well.
Yeah, now
we will be able to solve, which we are currently not able to solve as well. Huh?
Yeah, we're always saying, now we can do small machine learning cases, but never the big ones. And I think what you see, when we invented LED lights, with energy consumption went down, but also the applications went up. Like you have this orb in Las Vegas that just consumes a lot of LED lights. So I think if you give people more power, they're also looking to push the boundary of their use cases. And I think you will. My guess is you will see that in machine learning and AI kinds of applications. So now, in the medical setting, you will not be surprised, but the medical records are a lot of free text. So there's a lot of power in text mining. And but it's an interesting problem, because it's like you want to distill if a feature from a free text field, like has this person diabetes, but typically it says it has no diabetes in the family. So there's a no there, and there's in the family there. So it's a double negation. Is it or not a double negation? But it's not about the patient. There's no diabetes in the family. So that to text mine that with a good model. That's the kind of use cases we would ideally do, but then we need to be a little bit further.
Yeah, and I also think if you really want to do real-time monitoring of stuff. So if you take a security application, for example, where let's say all the banks in the Netherlands want to share their I don't know, logging with each other.
Some alerts, yeah.
Some
Yeah.
alerts.
Yeah.
You can't wait for a day to compute it, right? So you need to do it faster than that, and you need to get like real fast threat intelligence on that. I think that's where you need the computational power for. That's one. And you also need like the more scientific breakthroughs that you mentioned with regards to finding what you're looking for in the data.
Indeed. Yeah, I think maybe it's good to make the distinction between inference and training of a model.
Mm-hmm.
And training is the heavy, the computationally heavy part. Inference in MPC is not that bad. So you could, but still you have a few seconds or sometimes a few minutes if you have a big model. But the cheap, quote unquote, cheap thing is inference. So if you want to do detection with secret data,
that should go quite fast.
That should work.
We already can solve that problem. That's what you're saying.
Yeah, but training like a model, that's different.
Indeed.
No, exactly. So if you would use the same data, Jeroen, to say, okay, now I'm seeing these sort of attacks happening or alerts happening from all these different organizations. What does it mean for an attack actually happening for a model that is being run by any other? So that sort of training that's a hard problem, I would say.
Yeah, retraining the model or improving the model,
that
that's
would be
hard.
A hard problem. Yeah.
Inference, and the funny, but what's the exciting thing? You can keep the data on which you do the inference. So you're, say, ABN AMRO, and you have these signals, and you want to have these signals evaluated, but they're very sensitive to you because it is personal data, or you can encrypt them first, run them through the model. And even if you have a proprietary model, you can even keep the model secret. So the funny thing about this MPC thing is the data can be, but the model is also...
The model can also be abstracted from the user and the organization.
Yeah, if you there was one, it didn't end up in a project for us, but we're still, I think there's still, from both sides, there's still interest. There was this company, I think it was photonic wafers or something like that, or acoustic wafers, something about chip manufacturing. And they wanted to detect impurities on these wafers. But if you train the model on wafers with impurities, you would that model would leak some of the intellectual property of the wafer manufacturer, because the model encoded some of that, trade secret, basically. But they wanted to scale that model over multiple providers or producers of wafers, so they could not share the model, just send it over email. And these kind of applications are interested where even the model could be sensitive. That we're now sort of a bit of a not sci-fi, but a bit more advanced scenarios.
Yes.
But those could be interesting.
Those could be the trends you're looking at, where sort of new use cases arising.
Indeed, for in the future.
So Toon, I would like to thank you for your truly valuable insights into multi-party computation. For organizations that are interested in exploring MPC, what practical advice would you give them for starting? Are there common pitfalls or best practices to consider?
Yeah, I think it's it solves a lot of legal discussion. So in my role, I talk a lot with the privacy officer and the security officer to educate about what's the technology about, where are the vulnerabilities, the risks, and how to mitigate. There's, in our opinion, if you have a use case where you are not pushing the boundary of the scale of the volume, so like it's a 1 million table of records, 10 million, so on, there's almost no reason not to use it. There is, of course, if you can share it in the clear and there's no risk of sharing data in the clear with your partners, then it's easier. Yeah. You can just look at the spreadsheet, and that's always more convenient. But we found a lot of collaborations are stuck on exactly this point, assessing the risk, and that it will make the risk assessment much more concrete. You know what is the in a lot of these old scenarios you were guessing what the residual risk was. In this case, we can make the residual risk very tangible, and I think that's how I would, if I were a CISO or a privacy officer, I would enjoy and try to understand the technology, and then it's really about, is this use case appropriate for us? Like, is this collaboration and the residual risk of revealing a statistic, is that still, because there could be risk in that as well. That's where the evaluation then focuses on. Yeah,
instead of like sharing the data.
It's all the risks,
it's more like the insights that you get from the data.
Exactly,
that also means, I think, because you said that some of the collaborations are stuck, or at least severely delayed, is in my experience. It will help with the risk assessment. I also assume that it will definitely help with like data process impact assessments and data transfer impact assessments.
Yeah.
Because you can rely on the organizational and technical measures that multi-party computation can provide you.
Yeah.
And if you use that platform, you don't have to redo your data process impact assessment and data transfer impact assessment all over again.
Indeed.
Or for every initiative that you're
Yeah.
wanting to do on the platform, you don't have to redo it over and over and over again.
I think Jeroen, that's such an excellent point. I think that's where the acceleration happened of such a technology. And I would say even one step further, right? A lot of CXOs, they think this is a problem that cannot be solved. So they have already put the idea, entertaining of the idea of the business case or this sort of processes, or they put it in the refrigerator, I would say, just to translate it directly from the Dutch. So I think the awareness to them, to the CXOs, to say, wait, you don't have to dismiss this problem because there is a technology advancement that's happening where you can actually see a viable business case coming out of here because you can now share data with each other.
Yeah, definitely.
Not share data with each other, but share insights coming out from the data without sharing that data. That's the beauty of it.
That's the beauty of it, yeah.
Yeah, I think for architects and for CISOs, it's. I would say if you want to abstract it to, it's just a function. It's a box with a power cord or with a network cable attached to it. It's of course we run computations over multiple servers, and that's all technically very interesting. But functionally, for an architect, this is a box, and you have your Databricks and you have your Power BI. But for some collaborations or for some data sources that you don't want to push into Databricks or directly accessible from Power BI, it's just a box that you put, and that's how our customers, they have Elastic or they have Databricks, and there's our box, and they collect data in this box in a different and secure way, for where it's, so maybe 80% of the data or 99% of data can still go to Databricks, but for those things that get stuck, you have the box, the network cable, and I think that's for architects maybe the functionality that you can add to the toolbox.
So are there any resources that you would recommend for our listeners to read, listen to, or watch to support their journey, to keep up with the developments in MPC? Or we will post these in our show notes.
There's more and more there's very interesting articles coming out about MPC. It's always a good starting point is the wiki page of multi-party computation. It's very readable, and it's
good to say. That's very readable. Good.
Also for non-mathematicians.
So for folks that are afraid, it is readable.
It is readable. Yeah. Of course, we on our website have lots of use cases, but I think there's a Slack community we call collaborative computing, and it was a Roseman Labs branded community, but we removed the branding and we're opening it up for other moderators. And there, I think over 100 people are now they are interested in, what's going on in collaborative. You have federated learning, you have fully homomorphic encryption, you have a few more of these techniques that are now
That's an excellent resource. So if you can get a Slack channel later, we'll add it to the...
And you can ask any question you like, and there's...
and also like that they are opening it up, right? It's not like a Roseman community of like customers. No, it's like everybody who's interested in the subject can join.
Absolutely.
And they can learn on what it is, ask questions, etc.
I think increasing the awareness, Toon, because that is for me was key. It's like, okay, we are now at a pace where technology helps us solve a problem that we didn't want to solve because we thought it was not solvable.
Yeah.
And creating that awareness with such communication, just if you're going to limit it to your organization, probably you're not going to reach that awareness the way you want it. So this is awesome.
Yeah, I think we were very lucky that in the healthcare space and in the public sector space, we were very lucky with National Cybersecurity Center embracing this kind of new techniques. In healthcare, there were a few influencers that worked a lot with different hospitals. And they also said, this is a building block. And I think, we've gathered that group into this collaborative computing community. And they're very willing to respond to questions.
Excellent.
It's not a very active community yet, but we are hoping to, by sharing the moderation, to make it a bit more.
So maybe this podcast can be shared there as well. Who knows?
No, of course. It's not a big audience yet, but 100 plus. And all interested in this kind of.
Excellent.
So Wikipedia, the Roseman Labs website,
or
Slack
send
community,
me an email or connect to me on LinkedIn. There's tons of stuff to read. The White House is producing interesting material about this.
Oh, wow.
And ENISA, the sort of the cyber agency in Europe. So there's lots of
there's happening. There's momentum.
Yeah,
there's
a little
momentum
bit.
there.
Yeah. Maybe a lot.
Okay, so last question, Toon. Our topic or our podcast is about change of the industry, change of the security professional, reinventing things within security, right? Could you please share an innovative strategy or method that you believe security professionals should adopt tomorrow? How should they change?
Yeah.
To, for example, deliver multi-party computation as a standard service or capability within the organization that they work for. What do the listeners need to do different tomorrow?
Yeah, I have two answers. I think one is what we talked about quite extensively today. Is consider it as a new tool, a new box in your toolkit, and I think you consider it as a vault, data safe house or something like that, and you have it now, and it works not on a massive scale, but it's for a lot of use cases. It's a powerful tool, and I think the topic that we briefly touched upon is this for cyber threat intel. So your audience is cyber professionals, and they need hot cyber threat intel and we're now investigating several sector collaborations where security operating centers can share their threat intel together to have a richer picture of what's going on. Yep. And one great example is how NCC started on this ransomware annual report that by the Melissa Group that ultimately sort of busted a ransomware gang. Yep. This all started with a collaboration platform, the SecureNet collaboration platform, as a sort of a small building block, but it unlocked a lot of new collaboration, ultimately leading to this getting at the right cyber threat intel and sharing, of course, also things outside of, but in the physical world. But I think it's how I saw it transformed these consortia. They started with sharing small spreadsheets, and now all of a sudden they energized this whole community. Yeah. And now the community is working on data, but they're also offline coming together for maybe hunting.
Solving the actual problem.
For solving the problem. It's also a motivator.
I still remember like when I was working for Aegon back in the days when I was part of the insurance ISAC, for example, and then every month or every 2 months we had a meeting. And when we wanted to share something that was happening to us and we thought it would be something that would interest the other parties in the insurance sector, we filled out a Word document and it got emailed around. And I think a lot of these insurance ISACs are still working like this together, right? So I think the power of like multi-party computation and the collaboration that it brings can definitely help speed up information sharing, raising awareness at other companies to look for similar activities, for example, on the network, if we talk about the security
I think so.
perspective of sharing information.
Yeah.
Well done. Thank you so much. Thank you for being our guest.
You're very welcome. I loved it. Thanks.
It was a great conversation. Thank you so much.
Yeah, I liked it too. Thanks for the opportunity.
So multi-party computation, I think a very, very promising and interesting subject to have on our podcast. Irfaan, what do you think of the episode with Toon?
So I thought it was a great episode, Jeroen. I really enjoyed discussing the matter, which is quite technical in nature, if you ask me, to really break it down in such a way that people could understand and can understand. And that's my hope, of course, that our audience, our listeners will really understand what sort of problem multi-computation, party computations is solving, and also how, at least a peek under the hood, how they're solving it. What stood and was very interesting for me is that in terms of talking about reinventing security, I think for me, there are two takeaways over here. One is if you're already busy as an organization with sharing your data with other organizations, so you can do computation, you can get more insight of that data to apply for your business processes. A multi-party computation technology or process can accelerate that for you.
Yes.
Right? So it can give you more safeguards to do your privacy checks, your risk assessments, and all those things. It makes it not simpler, but it gives you more concrete pointers of what you should be looking at to make sure, to conclude actually, can I share my data, yes or no? This way. That's one. And secondly, I think this is really an eye-opener for me as a security executive, talking to executives, right? IT, but also business executives. What I see is that a lot of these executives already know that these use cases that they could have as business cases for their organization, that they would just not entertain that anymore because it's impossible to share your company proprietary data with other companies.
Yes.
So I think there is one call out that I want to do to our listeners as well, to spread that message of awareness to the business executive, to really look at what was not possible 10, 15 years ago and the assumptions that they made to put all these use cases from a business perspective, just park it and not entertain it, to really take it out again and really look at it from a new technological improvement and innovation that has happened or is happening, and see what is now possible. Because I think the number of use cases where this can be applied and the number of businesses where multi-party computation can be applied will grow. So I'm going to give it back to you. I'm very interested to know what you have got out from the session.
Yeah, to me, it's the realization that we as information security professionals need to be aware of this technology and then asks ourselves the question, what can we do more than just policies, right? You can say in your policy, share data security, encrypted, do data minimization, the data retention period should be X, right? I would highly encourage every single security professional or privacy professional to take this technology and make it a default service within their organization. You can create just a default service, a data collaboration platform that has all the controls in place: data retention, data minimization, encryption, logical access, you name it. And make that a service so that not a product team or a CXO needs to think on how they can share data. Be aware that your company probably wants to share the data because information is what fuels companies nowadays.
Businesses nowadays.
So there is a business need for it. Start finding partners in the organization that you work for to set this up as a service so that they can use it. That is, I think, my key takeaway for today.
Lovely. And just to add on that, Jeroen, because you're triggering me, CISOs always say, we want to be that business enabler.
Yes, this
is the opportunity.
This is a business enablement. This is what you do.
This is the opportunity.
This is what you do. This is how you reinvent security.
Excellent.
Yeah. So thank you so much for joining us today in the Reinvent Security podcast. We appreciate you taking the time to tune in and explore reinventing information security with us. In case you missed any of the details or want to dive deeper into the resources we discussed, make sure that you check out our show notes. There you will find links to our social media platforms as well, and all the resources we referenced during this episode. We're always looking for your input. If you have specific questions or if there's a dream guest that you would love to hear from in our future episodes, then shoot us a message or LinkedIn or send us an email. Your suggestion will definitely fuel our curiosity. Don't forget to subscribe to the Reinvent Security podcast on your favorite podcast player to stay updated with our latest episodes. Your ongoing support means everything to us. We'll be back next month with other exciting episodes. Until then, take care, stay curious, and we are looking forward to having you with us again. Cheers.
Bye-bye.
Bye-bye.